Thanks for joining us here on 9 News Plus. I'm meteorologist Chris Bianchi. Many of you know that this week marks the 10-year anniversary of the most devastating flood in recent memory to impact the state of Colorado, the September 2013 floods, which led to more than $1 billion worth of damage. 9 people lost their lives as a result of this, and countless homes, businesses, and other buildings were destroyed by this flood. And we're going to get into some of the details about what led up to the flood and also just how much rainfall that we saw from it. But for starters, here on 9 News, we've had all sorts of stories all week long about the survivors and the aftermath and the reconstruction of these towns, specifically Lyons, Jamestown, some of those hardest hit communities from this system. But let's start things off with a bit of a broad overview in terms of what we saw from the September 2013 flood. So essentially what happened, and many of you who were around during the time might remember, the thing that stood out about the September 2013 flood was the fact that it rained heavily. Now, here in Colorado, we can get heavy rain. What doesn't often happen here in Colorado, and what basically never happens, is it just doesn't rain for a week, and it just did not stop raining for essentially 6 to 7 days, starting on September the 10th in a few places. September the 11th was the main event, so to speak. That's when the heaviest rain kicked in, and it didn't stop until really September the 17th is when the rain did not end. And the reason being was we had a stalled storm system over the western United States. Now, this storm system, the one, that big L that you can see on the left-hand side of your screen, we often get these kinds of storms, but they tend to take place in November, in December, in January, in February, and that's when the jet stream's at its strongest. And the jet stream can help push these systems along. But when you get a storm system like this in early to mid-September, the jet stream is basically gone. There's nothing. Think about a train off of its tracks. That's the way to think about the September 2013 flood and the area low pressure that led up to it. It was a train off the track where there was nothing able to steer the system along, and therefore it just sat, it parked, and it spun up a ton of water. And also worth noting that sea surface temperatures in the Pacific and the Gulf of Mexico were really, really warm in 2013, which meant there was more water flowing north here into Colorado. So we were able to tap into tons of monsoon moisture. We had a cold front that sat right over us. We had a lifting mechanism. We had a lot of water. We had a stalled storm. We had the, unfortunately, perfect recipe for what happened. And that was a flood that has about a 0.1% chance of happening in a given year. So again, a 0.1% chance of something like this taking place. And this was the result in terms of those rainfall amounts. When we tend to get these kinds of sorts of setups where we're talking about tropical moisture, it doesn't necessarily blanket an entire area. What tends to happen, and this is exactly what happened with the 2013 flood, is we saw a couple of very narrow corridors of extreme rainfall. You get, if you've ever been in a hurricane, or you know anything about a tropical storm or a hurricane, and this is kind of a similar setup in the mechanism in terms of what led to this rainfall. Point being, you get these kind of little slivers, these very narrow bands of just incredible rain. And so, for example, Boulder picked up almost 18 inches worth of rainfall, including, by the way, 9+ inches in a single day, while Denver, downtown Denver, had about 4, in some cases as low as 2 inches worth of rainfall. Of course, there's only 25 miles that separate Boulder and downtown Denver. And so when you're talking about that stark of a difference between two places, like what happened on September 2013, that is due to the mechanism of tropical moisture. When you're getting a tropical system, when you're getting a hurricane, something like that, you tend to get these little narrow bands where you get this incredible rainfall. And by the way, notice how the east side of town, C470, Aurora, South Aurora in particular, saw as much as 16 inches worth of rainfall in a single week. Well, again, downtown Denver, 10-15 miles to the west, saw about only 2 to 5 inches worth of rainfall in the central part of the city. So again, that's one of those things to kind of keep in mind with the system, as we saw these just very localized narrow bands of extreme rainfall. And here's another look at it. Here's kind of a map showing you those extreme totals, really concentrated in two areas where we saw as much as 10 inches worth of rainfall. Again, northern Colorado, Greeley, mostly left alone, 2 to 4 inches worth of rainfall, though it's worth noting that, of course, Greeley sitting on the South Platte River. and a lot of Milliken, a lot of areas on the South Platte were really hard hit by the flooding, and the headwaters for a lot of the streams, creeks, rivers that flow down into the Front Range. Of course, the headwaters, notice Estes Park, Netherland, those purples, those white spots that you're seeing on your screen, that is where we saw as much as 20 inches worth of rainfall from the system. And that's also, in a lot of cases, the headwaters for those creeks and streams. So just flow down. You know, essentially, think about pouring a huge bucket of water on the top of a slide. That's basically what happened. Kind of one way to think about it is you take a bucket of water and you pour it at the top of the slide, and it just goes down. That's essentially what happened in this case with those, again, creeks, streams, rivers that invaded the Front Range. And also, of course, that narrow pocket on the east side of the city that really, really impacted downtown Aurora, downtown Denver. So here's a look at those top weekly rainfall totals that we saw from the storm system. This is, I pulled this from a couple of CoCross stations, weather stations from the week of September the 10th through the 17th. We saw about 18 inches worth of rainfall in East Boulder. I mean, my goodness. For context, Boulder averages 19 inches worth of rain and melted snowfall in a year. So we saw, what, 80% of 90% of your average annual rainfall in the span of 7 days, including, as I mentioned, 9.08 inches worth of rainfall in a single day there in Boulder. So the official total in downtown Boulder was 16.9 inches, east side of Boulder 17.7 inches, however you chalk it up. Again, for context, Boulder gets about 19 inches of rain, melted snow equivalent in a given year. Any sort of rain, hail, graupel, snowflake, all that water in a single year comes out to about 19 inches, and you got 9.08 inches in a single day. So again, think about getting 45% of your average annual precipitation in one day. Stunning. And also, look at this too. This to me might be the most impressive stat, and of course in the worst sense here in terms of what we saw in the September 2013 flood. The single day rainfall record was set in the storm, and Fort Carson picked up about a foot of rain in a single day. That was on September the 12th. From midnight September the 12th to midnight September the 13th, Fort Carson picked up 11.82 inches worth of rainfall. I mean, again, when we're talking about numbers like this, when we're talking about rain of this level, it is just, the only way to put it is this is truly off the charts, and hopefully something we won't see again anytime soon. But there were a lot of different factors that led to this kind of rainfall, and I was showing you that here. In fact, I might go back to this map quickly just to, again, show you the overall setup that led to the September 2013 flood. And there's this stalled area low pressure that sat and meant that even after we got that deep tropical moisture on September the 12th, September 11th, September the 12th, that just didn't stop raining. And that's thanks to, again, this mechanism that you're looking at here on your screen. We were able to tap into tons of moisture out of the Pacific, out of the Gulf of Mexico, stalled low to our west. That meant we were just drawing up nonstop moisture. And that cold front, the way to think about that cold front, that the little blue triangles there on your screen, think about taking a wet sponge, and if you ever have a wet sponge or wet cloth, right? The cold front is essentially squeezing out that moisture, because when you get a cold front like that, that gives you the lifting mechanism. So you can have a ton of water in a given day, right? If you have a ton of water available in the atmosphere, you need something to kind of lift that up in order for it to condense into precipitation, right? Point being, generally speaking, you kind of need two things to get rain or showers and thunderstorms. You need one, you need moisture. We certainly had that on the week of September 2013, but it was that cold front that sat right over the Front Range that essentially took all that water in a sponge and just squeezed it out. It just meant nonstop squeezing of that moisture, and that's why we were able to get about a year's worth of rain in a week in a lot of areas in the Front Range, on the east side of the metro area. By the way, I was talking about Aurora. Boulder averages a little bit more rain and melted snow in a given year than Denver does because of the upslope flow. Boulder closer to the foothills. Denver and most of the metro area averages about 14, 15 inches worth of rain, worth of precipitation in a given year. So Aurora picking up 15, 16 inches worth of rainfall. That was literally a year's worth of rain in a single week. So just, again, stunning totals, and hopefully it gives you a good idea about what essentially led to it and why this particular flood was so horrible, and again, hopefully something that we'll never see again, or at least, there's certainly a chance for seeing something like that, but you got about a 0.1% chance of seeing something like that in a given year. And again, very, very unique setup in the worst of senses leading to that September 2013 flood. And hopefully it has given you a good idea about what led up to it, and also some of those stunning totals behind the rainfall that took place back on September the 10th through September the 17th of 2013.